Hello, Honors Geometry, and welcome to our 5th video of the year. This is the 5th video of our unit, and we are almost done here with this first beginning unit on factoring and solving quadratics. Today will be our last video on solving, where we're going to spend the last part of our unit on the solving quadratics type. So right up before this lesson, we talked about factoring trinomials when a was 1. Okay, and a reminder, remember our standard form of a trinomial is ax squared plus bx plus c. And we talked about what happens when this is 1, or really on a lot of them, we saw that there was no number in front of that x squared. Okay, well today we're going to talk about what happens when this cannot be 1. So we cannot take a GCF out to make this 1, and it's going to have another number there. So to get into that, reminder, first step in factoring, which, okay, I've been asking you a lot of this in our live sessions on Zoom. You've seen it in all the videos. The first step in factoring is to check for a GCF. Okay, we're checking for that greatest common factor. Okay, so now, what I have written out here is the steps for factoring when a is not 1. Now, you're going to look at this and you're probably going to be like, wow, that's a lot of steps, but a lot of it comes with seeing what I'm going to do in these problems where it makes sense. If we walk through them, first off, check for a GCF if there is one factored out. The next thing, we're multiplying our A and our C values to make a new C value. Okay, we're going to write out the factors of C and see which pairs add up to B. Take the factors from the last step, rewrite the original, we'll split the B. Okay, group, factor, and all that. I'm going to ignore all that. Just get that out of your brain. And we're going to get right into the process, and the process is the same each time. So I think that is going to help us work through all of this. It looks like a lot, but when we get down to the actual problems, I think it will make a little bit more sense. So let's get right into it. So always remember, the first step into factoring is to go through and look at a problem and see if it has a GCF. Okay, and now if I go here off to the side, okay, I'm going to work here on another sheet of paper for our GCF. We talk about here, if I label that A, so that's what we're on, we talk about it in terms of numbers and in terms of variables. So the numbers that I see are my coefficients and also my constant or number at the end. The numbers on this problem are 2, 5, and 3. The variables in this problem is I see the variable of x. So now on my numbers, factors of 2 are 1 and 2. Factors of 5 are 1 and 5. Factors of 3 are 1 and 3. The number and the only number that all of them have in common is a 1. Remember when we say it has a 1 in common? This is another way of saying no GCF for the numbers. Okay, now if I think about it for the variables, okay, I see x. Remember, our question we're going to ask is, does each term have an x? Okay, and each is the key word. Okay, sometimes I said every, each, they mean the same thing. Well, first off, my 2x squared has an x, my 5x has an x, but not my 3. Since my answer to this is no, there is no GCF for my variable. So now, the only thing you do have to be concerned with is, even though there's no GCF for the numbers and the variables, you have to look to make sure that your first term is not a negative. If my 2 out in front of here was a negative 2x squared, even though there's no GCF for my number or variable, I still have to take out a negative 1. you always want your problem to start out with a positive and not a negative. Okay, if I look back up here, the steps, that's first step. Check for a GCF. Okay, now if we get into this process, first thing I need to realize and identify is my A, my B, and my C value. Your A, remember up in that standard form, if I bring this down a little bit, is in front of the x squared. In front of my x squared is a 2. Your B is what's in front of your x, which is a 5. Your C is your constant, or the number at the end, which is 3. The new step when A is not equal to 1 is to multiply your A and your C values. So I'm going to take A times C. That would be 2 times 3, which is 6. So I took A times C, 2 times 3 is 6. Now, that is step 2. Multiply A and C to get this new quote unquote, I'm doing those quote marks, C value. Now, I want to write out the factors of the new C to see which ones add up to B. So, this goes back to that last lesson. Remember in the last lesson, a reminder, if we write it out here. Okay, for our C value, if our C was positive, that meant the factors were either both positive, which I'm going to abbreviate, or both negative. That happens if our C value, and now we're going to say the same thing with our new quote-unquote C value. And then we also talked about when C was negative, it meant factors were one of each, which meant one negative and one positive. Okay, and so we're going to look here and look at that. So now, on this problem, my C is positive. So my factors are going to be both positive or both negative. We'll have to determine which it is. So if I look at 6, my factors of 6 are 1 and 6, 2 and 3. Okay, those are my factors where they're both positive. Now I'm going to look at the factors that are both negative. They're the same numbers. They're both just getting the negative side. Okay, that is halfway through this. We write out the factors of C. Now we want to know which ones add to our B value. My B value is 5. Just like the last lesson, I'm going to go here to my calculator and I'm going to start adding factors. 1 plus 6 is 7. That's not 5. 2 plus 3. Ooh, there's my 5. There is only one set of factors that will add to the B value. Right here is the new step. The new step, sometimes you hear teachers call this splitting the B or splitting the middle term. I'm going to take these factors of 2 and 3, and I'm going to split my 5x into a 2x and a 3x. It does not matter the order they go. So I could do 2x squared. Now my 5x is going to be the 2x and the 3x, and I keep the A and the C terms the same. Your B is what split up into these factors that you found here. Okay, that is take the factors and split the B. Now, once you get here, you're going to group the first 2 terms and the last 2 terms. Okay, we're going to go back and we're going to find the GCF between these different groupings that I have made. So if I were to cover up and look and say the only thing I see here is 2x squared plus 2x, you're going to look and say, what is the GCF? So if we have to, if I use this paper that's covering up, Okay, we're going to talk about it in terms of numbers, in terms of variables. The numbers in this grouping are 2 and 2. Remember when we talked about GCF? If your numbers are the same, your GCF is going to be the same thing. So since my numbers are the same, they are both 2, my GCF is going to be a 2. Okay, in terms of variable, I see x's. And now both of my terms have an x. If both of them have an x, your GCF is that x to the lowest exponent I see. Exponent of 2, exponent of 1, that's my lowest. So 2x is my GCF. I'm going to look and say, factor out a 2x. Take your original and divide it by that GCF. That's going to give me 2x. 2 divided by 2 is 1, but I have 2 x's and I took out 1. I'm left with an x. Plus 2x divided by 2x is 1. There is taking out the GCF of that first grouping of 2. We're going to do the same thing with this other grouping. So it's like I'm covering up that 2x and all that right now. Right now I see a 3x plus 3. Okay, if I bring this over here, okay, the numbers I see are 3 and 3. My variable in the problem is x. In terms of GCF, if your numbers are the same, your GCF is going to be that same thing. In terms of x's, there's an x on this 3x, but there's no x here. So there are no GCF for the variables. The only GCF is 3. Okay, so I go back here to my problem. My GCF is outside, and I take the original what's in that parentheses and divide by that GCF. Okay, I look and I say GCF comes down. 3 divided by 3 is 1, but since there's an x there, we're not going to write it. 3 divided by 3 is 1. Okay, I have grouped the first term and I factored out the GCF. What you should get is once you have grouped and factored out the GCF, inside your parentheses should be the same thing. If they are not the same thing, you have done something wrong. So this is a checking point to tell you whether or not you're on the right track. Notice how x plus 1 is my same thing in the parentheses. Your final answer is to write the same thing that was in the parentheses, and in the other parentheses for your factor, it becomes these GCFs that you've taken out in order from left to right. So reading this left to right, I have 2x, and now I have a 3, but since there's no sign in front of it, remember that means it's a positive 3, so I put the plus. If you took out a negative, this would have been a minus. If you take out a plus, it's a positive. That's my final answer. That is the answer in factored form. Now it says we can check this with foiling. Let me write down our answer here real quick. Okay, I wrote down our answer. If we check this with FOIL, x times 2x is 2x squared. X times 3 is a positive 3x. 1 times 2x is a positive 2x. 1 times 3 is a positive 3. I can combine my 3x and my 2x because they are like terms. So I get 2x squared plus 5x plus 3. Once you FOIL, you should get back to, and I notice here if I compare, get back to this original trinomial that was at the beginning. That's my final answer. Okay, these problems, it just takes time to make sure you're doing all the steps. It looks like a whole bunch up here, but the more times we practice it, the better and easier I think it gets. So let's go down here to the next one. Okay, so here on the next problem. Okay, the first first thing I'm going to check for is a GCF. So first off, I hope you notice not every term has an x, so I don't have to check my variables. I'm now really just concerned with my numbers. 5, 17, and 6. Factors of 5 are 1 and 5. 17 is 1 and 17. 6 is 1, 6, 2, and 3. 1 is the only number that they have in common. Okay, no GCF then. The only thing you have to watch out for is if this beginning number, if this would have been a -5, even though there's no GCF with my number or my variable, I do need to take out a -1. Okay, so now I'm going to start through this process again. The more times you see me work through it, you work through it, the easier it gets. I'm going to identify A, B, and C. A is what's in front of x squared. B is what's in front of x. C is the constant at the end. Notice you take the sign. This was a positive. In front of my 17 was a minus. That means it's negative. And then C was 6. Now I'm going to take A times C. That'd be 5 times 6, which is 30. Okay, if I go back here to what we wrote down here. Since C is positive, it's a positive 30. Both factors are either positive or they're both negative. So, listing out factors of 30. 1 and 30. 2 and 15. 3 and 10. 5 and 6. There's all my factors where they're both positive. Now I'm going to write them out where they're both negative. -1, -30. -2, -15. -3, -10. -5, -6. Out of these factors that I have listed here, I'm looking for which one adds up to my B value. My B is -17. So again, I can go to the calculator to help me. I can look and say 1 plus 30. Nope. 2 plus 15. No, I'm looking for a -17, not a positive. 3 plus 10. Nope. 5 plus 6. Nope. -1 plus a -30. Nope. -2 plus a -15. Yes. Here is the set that add up to a total of -17. Okay, once you get these factors, we're going to rewrite our trinomial so the middle term is split up into these two values. So I write 5x squared. My middle term of x becomes a -2x and a -15x. It doesn't matter the order. So we'll do -2x minus 15x plus 6. I just wrote them the same way that I have them written here. Same order. So first two, last two get grouped. Now I'm going to look through the GCF of both of these. So my first one that I see, I have, if I cover up, 5x squared minus 2x. Okay, so if I look here, numbers, I have 5 and 2, 1 and 5, 1 and 2. Okay, in terms of numbers, there's no GCF. And since my leading one isn't negative, I don't need to worry about a -1. In terms of variables, both of them have an x. So that means x to the lowest exponent has to be my GCF. X, this is x squared, so it'd be a 2. This is x by itself. So x by itself is x to the power of 1. That is my GCF. So I look here and I say x, 5x squared divided by x minus 2x divided by x. I take my original problem and I divide it by that GCF. 5 divided by nothing, or 1 is 5. I have 2 x's. I'm taking away 1. I'm left with 1. -2 divided by 1 is a -2. I had 1 x. I took away, so you're left with none. Now you're going to work with that second parentheses. Okay, in my second parentheses, if I go down here below, again, I have numbers, I have variables. The numbers that I see in this problem are a 15 and a 6. Factors of 15 are 1 and 15, 3 and 5. Factors of 6 are 1 and 6, 2 and 3. Notice how they both have a 3 in common. So to write out my GCF will have a 3, but since my leading term is negative, it has a negative 3. Your leading term tells you whether you take out a positive or a negative. And then for my variable, they both don't have an x, so the only GCF is negative 3. So I'm going to write out in front my GCF, take what was inside the parentheses and divide by that GCF. So I divided everything by a negative 3. I have negative 3. Negative 15 divided by a negative 3 is a positive 5. I did nothing with the x's. 6 divided by a negative 3 is a negative 2. Notice, once you take out the GCF, what is in your parentheses for both of them should be the same. If it is, it tells you you've done the problem right. Your final answer, what is in the parentheses, gets written, and then your GCFs from left to right in the order. So x, since this was a negative 3, it's a minus 3. There is my final answer. This is the problem in factored form. Okay? So it gets easier the more you work through it. It's like a process. So if we look at some more here. So looking here at the next problem. Okay? Just like we have been working on, we're going to check for a GCF. First off, the easiest thing I look for is not every one of these have an x. So I know there's no GCF with my variable. I'm just dealing with the numbers. I have 6, 5, and 4. Ignore the signs. 1 and 6, 2 and 3. 5 is 1 and 5. 4 is 1 and 4. 2 and 2. The only number that they have in common is a 1. Now, since this is a positive, I don't have to take out a negative. Okay, remember when it's 1, there's no GCF. The only thing you're concerned for is if it has a negative. Okay, no GCF, so we go right here. Identify A, B, and C. A is what's in front of x squared. B is what's in front of x. C is the number at the end. Okay, and take the signs with it. Now I'm going to do A times C. 6 times a negative 4 is a negative 24. Now, this gets us something new. So if I look back here, if C is negative, factors, I have one of each, one negative and one positive. So listing out the factors of 24, I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. For the first set of those, I always make the first number be negative. For my second set, I'm going to make the second numbers be negative because it says if C is negative, 1 is positive, and 1 is negative. Now, once you've listed your factors with all the signs you need to, you're looking for the ones that give you B. I'm looking for the ones that give me negative 5. Okay, if I look through those, 3 and negative 8 is going to give me negative 5. I'm going to split my middle term of x into a 3x and a negative 8x. It doesn't matter the order. You get to choose. So I normally just do them in the same order I have it here. So I'll do 3x minus 8x. So 6x squared, since a 3 was positive, it's a plus 3x minus 8x minus 4. Once you have split, I'm going to group the first 2 terms and the last 2 terms. Here on the first term, I'm going to find the GCF. The GCF of 6x squared plus 3x is a 3x. And I'm going to factor that out. Okay, to factor it out, you take your original problem and you divide by it. So I write the GCF. 6 divided by 3 is 2. I had 2 x's, I took away 1, so I'm left with 1. Plus 3 divided by 3 is 1. I had 1x, I took it away, so I have none. Okay, there's taking the GCF of the first set. Okay, now out of negative 8x and a negative 4, they have a GCF of a negative 4. Okay, why it's negative is because this 8x, the beginning of it is negative, and they both can share the highest number of 4 in factors. Okay, GCF, take what's inside and divide it by that GCF. So I took that negative 8x minus 4 and divide it by a negative 4. Negative 8 divided by a negative 4 is a positive 2. I did nothing with my x's. Negative 4 divided by a negative 4 is a positive 1. Notice, what's in the parentheses is the same, so I'm good to go. Write what's in the parentheses, that's the same. Now you're going to write what you took out as GCFs in order from left to right. So 3x, a negative 4 would make this a minus 4. There would be my final answer. Okay, like I said, the more we work through this, the easier I think it gets. Okay, looking at D. Okay, these last 3 I'm going to tell you we're going to get some GCFs on them. So if I look at D, my numbers are 12, 2, and 2. I would have realized I had a GCF of a 2. There's nothing with the variables because they all don't have x's. So now, 12, if I do this, I'm going to just put the divide by 2 clear up here on the top. So I am. 12 divided by 2 is 6. I did nothing with the x's. Plus 2 divided by 2 is 1, but since there's an x, we don't write the 1. And then a negative 2 divided by 2 is a negative 1. So I've taken out the GCF. Now, this is still a trinomial inside, and my A is not 1. So I'm still left with the same process. Basically, you're going to factor what's inside of the parentheses, and at the end, attach the GCF. So if I would ignore this and say this now is my new problem. A is 6, B is 1, C is negative 1. Multiplying A and C. A times C would be 6 times a negative 1, which is negative 6. If your C value is negative 1, it is like this last problem where you have 1 of each. Factors of 6, 1 and 6, 2 and 3. For my first set of factors, I let my first number be negative. When I write them again, my second number is my negative. I'm looking for, out of those factors, which one give me my B value of a positive 1. Well, that's negative 2 and negative 2 and a positive 3. So, ignoring this GCF, I'm going to write this original problem. 6x squared minus 2x plus 3x minus 1. I wrote it in the same order there. Okay, if you wanted to, sometimes you'll see problems where they put that in parentheses again and carry the GCF, but you don't need to. Okay, nothing else. Now I'm going to think about putting the first 2 and the last 2 in its parentheses. The factor of 6x squared minus 2x is a 2x. Okay, I'm going to take and divide each of these by a 2x, what we got for the GCF. 6 divided by 2 is 3. I had 2 x's, I took away 1, so I'm left with 1. Negative 2 divided by 2 is a negative 1. I had 1x, I took it away, so you have none left. Out of 3x minus 1, I would realize there's no GCF. Okay, if there's no GCF, simply we look and say on these problems, take out a 1. All as it does is it keeps your problem the same inside. I just have something outside. 3x minus 1 are shared. So 3x minus 1. From left to right, I have a 2x and I have a 1. If there's no sign out in front of it, I assume it's positive 1. The last thing to do is to write out the GCF from that original first step, clear out in front, and there's your final answer. Okay, the more times we work through this, I'm going to tell you, the better it gets. So the more, when we practice this in class, eventually this will make sense. I know it's a lot of steps, but it will click here eventually. So 15x squared minus 18x minus 24. First off, not everything has an x, so there's no variable for a GCF, but there is a number. Out of those there, the number that they all share is a 3. So I'm going to divide my original problem by 3. Okay, put it outside. 15 divided by 3 is a 5x squared. Negative 18 divided by 3 is a negative 6x. Negative 24 divided by 3 is a negative 8. Now, it's like you ignore this 3 out in front. A, B, and C. A is what's in front of x squared. B is what's in front of x. C is your constant at the end. Now you're going to take A times C. 5 times negative 8 is a negative 40. I'm going to list out my factors of negative 40. Since my C value is negative, I'm looking at one of each. 1 positive and 1 negative. 1 and 40, 2 and 20, 4 and 10, 5 and 8. For the first step, I let my first numbers be negative. When I write them again, my second numbers are my negative. Okay, I'm looking for which one gets me my B value of negative 6. It'd be right here at 4 and negative 10. I'm going to rewrite what was inside that parentheses into the middle term is going to be a 4x and a negative 10x. Plus 4x minus 10x minus 8. I always normally write it in the same order. Put your first 2 in parentheses. Put your last 2 in parentheses. The GCF out of 5x squared plus 4x is only an x. Okay, if I like to say this is 5x squared plus 4x divided by x. Okay, I'm going to bring down another piece of paper so I have more steps here and more room. I have x. 5 divided by, if there's nothing there, it's a 1, so that's 5. I had 2 x's, I took away 1, so I'm left with 1. Plus 4 divided by 1 is 4. I had 1x, I took away 1x, so I have none. Now, on my second set of parentheses, negative 10x minus 8. First off, I know I need to take out a negative, since my leading term is negative, but they both have a 2 in common. So I take negative 10x minus 8 divided by a negative 2. Negative 10 divided by a negative 2 is a positive 5x. Negative 8 divided by a negative 2 is a positive 4. Notice, same thing in the parentheses. So I can go to my final answer. One parentheses is what do they have in common. Your second parentheses is to write out your GCFs left to right. Starts out with x. Since it's a negative 2, it makes it minus 2. Last step is if you had a GCF clear back at the beginning, that gets written clear in the front. There's my final answer. Okay, it's a long process, but I'm like to say, once the more we work with it, the more it's going to be like common to you to do this. Okay, looking at our last one. Okay, this one has a GCF of a 5. Okay, they don't have any variables because they both don't all have x's. 10 divided by 5 is 2. plus 75 divided by 5 is 15. Plus 35 divided by 5 is 7. A, B, and C. A is 2, B is 15, C is 7. A times C. 2 times 7 is 14. I'm listing out factors of 14. They're both positive. If they're both positive, factors are both positive or both negative. That's what it is when C is positive. Okay, 14. 1 and 14, 2 and 7. There's both positive. Here's both negative. Okay, I'm looking for which one gets me to B, which is a 15. 1 and 14 get me there. So now, I'm going to rewrite my 15x as a 1x and a 14x. So I'm ignoring this GCF and I'm going to say 2x squared plus 1x, which I'm going to just write as x, plus 14x plus 7. There's my 1x and my 14x. First two, last two. Okay, GCF out of 2x squared plus x is an x. So I take 2x squared plus x. I'm going to divide everything by an x. Okay, 2 divided by 1 is 2. I had 2 x's. I took away an x. So I'm left with 1. Plus x divided by, or 1 divided by 1 is 1. There's no numbers, but there's 1s there. X divided by x would be none because I had 1 and I took away 1. Okay, out of 14x plus 7, my GCF would be a 7. 14x divided by 7 plus 7 divided by 7. Take your original, divide by your GCF. Okay, carry this. 14 divided by 7 is 2x plus 7 divided by 7 is 1. 2x plus 1 in parentheses, they're the same. So you can go to our final answer. The same in the parentheses. What's outside left to right is x plus 7. GCF at the beginning goes clear out in front. There's my final answer. Okay, these problems are going to take time. We're going to continue to practice this in class, next class, so you'll have more practice with this. The more times you work with it, the easier this process gets and the more times you remember it. This is the way that you'll factor in Algebra 2. They always split their B or split the middle term. So we're going to continue also practicing with this in geometry all year. So when you get to Algebra 2, this is easy for you to work with. If you come in with this knowledge, Algebra 2, when they get into factoring, you're a step ahead of everyone. Okay, so hope you enjoyed the lesson, and I will see you in class to cover this more. Have a great day, everyone.